Yes, sir.
Okay, so let me just take you through where we had stopped. I don't remember. I think if I'm opening too many copies of Visual Studio, it's actually slowing me down. But maybe try closing other windows that I don't need right now. In fact, all of my browser windows can be closed. Okay, so while this is happening, okay, you'll have a test scheduled at 4 today evening. Okay. My advice to you about this is simply to read the all the options there before you answer. A lot of times I've been based on conducted similar papers that I've been told that, oh, we knew the answer but didn't read the question well enough. So my advice to you, based on what feedback I've received from the previous people, is that if you can read the question well enough, okay, then hopefully you should be able to answer it easily. Sometimes you read it through in haste, and that's what causes that. Okay, so this is the last example that we had worked with, where we had delegates and we had actually called either delegates, either functions that had a return value or didn't have a return value. Okay. And also we tried calling it from the same class, different class, how it mattered. So these are the things that we have last done. Okay. So I'm going to continue with this example, in fact. And let me just copy paste this, for example. So I'll start off with one situation where you could use delegates. Okay, before I go there, I think I'd asked you all to do something. I had asked you all to tell me what would happen if you had multicast delegates that had a return value, and to observe the behavior and to come up with, tell me what happens there. So did you all try that out, and what exactly happened? Has anyone tried this out? Multicast delegate with a return value? I do remember asking you all to try it out.
Yes, sir. I missed that part. I was busy with the assignment.
So anybody else who's tried it out and would like to tell me what happens then?
Yes,
If you
sir.
have multicast delegates that have a return value.
Sir, if we have multicast delegate with a return value, so when we call the invoke, if we have called couple of times invoke, only the final invoke result will display.
Correct. So what happens here is the function gets called. Supposing I was calling add and subtract both with the same delegate. So both the functions get called. Add also gets called, subtract also gets called. But the return value that you get will only be from the last function that you're called. So if you're called add first and subtract second, then it will only give you the return value from subtract, not from add. So that is what I wanted to check out. Okay, we cannot change that. It will always work that way only. So if you have multicast delegates that have a return value, then maybe it's not a good idea to call them with multicast delegates, because you're only getting the last value in there. Are we clear on this, everybody? So this is something that I had asked you to try out the other day, and some of you all have tried that out. Okay. I'm going to try out another example here. So what I want to do is, we've been looking at the how of the delegate. We've been looking at how the delegate is called, but we have not really gotten to the situations where you can use delegates. So whatever we've done the other day, we could have done that without delegates also. We could have done that with a normal function call also, right? Other than multicast delegates, everything else that we did with delegates, everything else was possible with normal calls as well. So today we are going to try out something which is really useful, wherein the function to call is received as a parameter. Right? So function to call is passed as a parameter. Okay. So I want to call this add or subtract function. And to do that, I'll use the same delegate that I've been using in my previous code. Right? And see what I'm doing out here. Static int, let's call this as pass function as a parameter. Okay. Now, how do you pass a function as a parameter? Essentially, what you have to do is pass a delegate as a parameter, and the delegate needs to have the same signature as the function. So del2 is my delegate on top, which has the same signature as add and subtract. So I'm going to say del2, let's say obj del2. And here I would do a return obj del2 of whatever. Let's start with 20, 30. Let's hard code some values out here. Okay, 20 and 10 have passed. Now, at the time of writing code, do I know which function is going to call? Do I know which function is this obj del going to call?
No, sir.
Yes. No. But I do know that it's going to call a function having the same signature as obj del, which takes two parameters and has a return value. That's what this line is indicating out. And which function to call will be decided here. Whereas I'm saying, console.writeLine, sorry. Console.writeLine. And I'm passing function or rather pass function as a parameter. And let me pass add. When I pass add out here, add is going to be received by obj del2, which is like saying obj del2 is equal to add. So what will this line do at this point? Supposing you're passing here, this is what is happening. Obj del2 equal to add. What is that doing?
Calling to add
Not
function.
calling it. It's not calling. It's pointing to add a function at this point. Obj del2 now at this point is pointing to add. And where are we calling it? We're calling it here. When we're calling obj del2 of 20, 10, that's where we are calling it. Okay. Now, just like I can pass add, I could have also passed subtract here. Right? I could have passed this as well. And when I do this now, the first time you'll notice it goes and makes a call to add, and the second time to subtract. So the first time it's adding the 2 and 20 plus 10, and then the second time 20 minus. Are we clear on this? Right?
Yes,
Questions, if any? Yeah. So what have we done with delegates? One possibility is the method to call is being passed as a parameter. All right. Now I have hard coded this to 2010. So every time it's going to call what? 20 and 10 only. Can I make it more flexible and pass any values that I want? What will I need to make? What changes in this case?
Params.
We don't need params here because
Parameter.
yeah, so we'll have to have two parameters, not the params if you're saying params array, not that. So int a comma int b, for example, and instead of 2010, I will now pass what?
A
A
and
and
B.
B. And while calling it, of course, while calling it, I'll
We
say
have to
add
pass parameter.
comma 20 comma 10 or subtract comma whatever 5 comma 1. So this is where I'm passing the values. So this makes it more flexible. It's just that instead of hard coding the values, I've now received the values here. So now this gives you 30 and then 4. Are we clear on this, everybody?
Yes, sir.
So this is one place where delegates could be used. Not the only place, but one place. Okay, somebody reminded me about params. Did you try out params? I'd asked you to try out params as well. Yes. How many of you have tried out params? Has anyone tried out params? I did mention params,
Sir,
right?
you mentioned to place it in an add function. I did that one
Correct.
only, nothing else.
Yeah, that one.
Yeah, that I have done.
Yeah. So I had asked you to do that, and in case you've not done that, then I might have an example open here. Okay, so look at line 107. Where, what am I doing here? What am I doing here in this case? Accepting,
Array of integers.
yeah, an array of integers as params. So when I'm expecting it as params, then I don't have to pass it as an array of integers. I can pass individual parameters out here. Where is that code gone? Okay, I think that code might have got misplaced, but I can actually call individual params out here to call individual elements out here. To call it, I could actually do it this way. Let's say static void main and console.writeLine. Now I can pass multiple values here. Let's say add of, let's start with 2 parameters. And these 2 parameters should be internally converted to an array of integers. And I can repeat the same thing with any number of parameters. So I can pass it with, let's say, 2, 3, 4, whatever. Okay. And no parameters as well. So in this case, I'm passing 2 parameters, 3 parameters, 4 parameters, no parameters. How do I know in the array, in this function, how do I know how many parameters have I received? Supposing you want to keep track of how many parameters are there, how could I keep track of that? What will tell me how many parameters have I received?
Length of that array.
Array.length would give you that. So I'm just running a loop here, and this is basically trying to do an add. I'm just running a loop here which does what? Which loops through all the elements and keeps adding that to the sum and returns the sum. So this is where I had asked you to try out the params. In case you have not tried it out, then you can try it out. Okay. How do I get the chat window? So this is my example for params. In case you want to try it out, you can actually go ahead and copy paste that and try that out. Okay, so anyway, coming back to this, let's move on to the next example with delegate. Now,
Hello, sir.
yes,
There is where keyword in there. What it is useful.
we have not yet come to where.
But in the
In the
about,
example, you can change it to int.
okay, sir.
You can change that to int. I was just explaining something and I just didn't change it. You can change it to int because it's an array of integers. So the same thing as you've been doing for any of your for each loop. Okay. Now we're going to try out one more example with delegates. Okay, so tell me one thing, if if I have to create or I have to call a function with a delegate, what is the first thing that I would need to do? What is the first thing that I need to do? Let's say, for example, if I had to call this display function of yours, what is the first thing that I need to do? Yes,
Create a delegate class.
Create a delegate class.
correct. Now, supposing the signature changes, okay, and let's say, take this. Can the same delegate class be used to call the second method also?
No, sir.
We have to
No,
create.
sir.
We have to create.
We have to create what?
We
A
have
new
to create
delegate
one
class.
class, delegate class
Another
with
delegate, sir.
the string argument.
Correct. So every time your signature changes, that same delegate class can't handle it. You'll have to create another delegate class and another and another and another. Now, like this, there'll be so many different functions with so many different signatures that you have. So how do you end up calling all of this? How do you end up actually working with all of this? So to do that, what you need to do is to avoid having to create your own classes. You can actually use some of the inbuilt delegate classes that are already given to you. And one of these classes is called as action. So let's look at action. If you look at action here is the delegate. What is the signature of action? Delegate.
Void.
Return type is what? Void.
Void.
And what parameters?
No
No
parameter.
parameter.
No parameters. So you can use action. Okay, and action I'm saying is an inbuilt delegate class. You can use action to call all functions that don't have a return type. That return type is void. And help me calling action now. Action, I want to call display, let's say, action one is equal to display. To call it, simply call it with O1. So what have we avoided right now? In this example, what have we avoided?
Creating delegate.
Creating our own delegate class. That step we avoided. We are directly now using action. Are we clear on this, everybody?
Yes, sir.
Yes, sir.
Okay. Now, action has an overload. If you look at this action is simple. I mean, if you look at the signature, what is the signature? Return type is void and no parameters. But there are other action options available here. So look at this action with angle brackets. Right? And if you go to the angle brackets, look at the first option here in T, where T can be any data type. This is a generic example that you're using. And in indicates that it's a parameter. So if you want to call this method, you want to call this display, I would simply say action of string. whatever, let's say O2 is equal to display. Why action of string? What is string
The
indicating?
method parameter is string.
Correct. So this matches the signature of this. Okay. And to call it, how do I call it now? O2 of whatever value that you want. Okay. Now, what if the method had more parameters? My int I, for example. What if I had to do this?
String, comma, integer.
Correct. So you have different overloads to action. So let's look at the different overloads to action. So first one was in T, one parameter. Next one in
Integer.
T1 comma in T2, not integer, in T1 comma in T2. Now in here indicates what? That it's a parameter. So in T1, T2, and then you have T3, T4, T5, all the way up to T16. So up to 16 parameters you can give. Up to 16 parameters. Are we clear on this? What if your method had more than 16 parameters? Then what? For more than 16, what do you do?
Create delegate.
Array
No, no array. No array. You can't create an array. No? Your method has more than 16 parameters.
Create
So,
another action.
No further action. You will have to create your own delegate class. Action can take up to 16 parameters. Action can point to any function that has 16 parameters. So no array. How are you going to create an array? I'm saying a function itself has 18 parameters, let's say. So how are you going to pass it in the array? You need to pass 18 parameters. Though. But to pass 18 parameters, these inbuilt actions will not work. Because our action can take up to from 0 to 16 parameters it can take. Anything more than that, and you'll have to create your own delegate class. Okay. So help me call the second display. Help me call the second display. Action of
String and integer. Int.
string, comma, int. Whatever. O3 is equal to display. And then to call it simply O3 of whatever, some string and some value. Are we clear on this, everybody? Are we clear with action? This is running the earlier code.
Yes, sir.
All right. So essentially, action is used for calling functions which do not have a return type, whose return type is void. All right. Now, what if I had functions which had a return type? Okay. So these functions now, some of them returning a string, integer, pool. So they have a return type. Now, what do I do in that case? How do I call these functions? So to handle functions with a return type, you need to use the func delegate. There's again an inbuilt delegate called func, F-U-N-C, func. Okay, short form for function. So let's look at the signature for func. It says, there's no overload without any of this thing. It says func of out t result. That's the first one. What does out t result indicate? If in was a parameter, out would indicate what?
Return type.
Return type. So we are saying that this function, right, can call a function, or this delegate can call a function which has no parameters and has a return type. This one. Okay. So I have a method here called get current time. which doesn't take any parameters but is returning a string. So help me call get current time with func, call out the code func of what?
String.
Func of string, carry on, call out the code.
Equal to
F1 is
O1,
is
let's say,
O1 equal to
equal
get
to
current time.
get current time. And then console.write line over. So this is returning a value. Okay, so func is used for any functions that have a return value. Are we clear on this, everybody? Questions, if any, about func before we try more examples? Clear? Okay. Help me call the second one. Get double. Func of.
int
Now look at this. In
Out.
T, comma out T result. In T, what does the in indicate?
input value.
Parameters.
Input
and
parameter.
out indicates the return type.
Return type.
Return type.
So help me for get double. Don't look at that code. It's not the correct code.
int
Int, comma,
int
int, comma, int.
Int.
What is the last int giving you?
Return type.
return type.
Return type.
Okay. So O2 is equal to get double. Are we clear on this?
Yes, sir.
And then console.write line O2 of whatever 10, 20, whatever number that you wanted, that's returning a 20, double of that. Returning 20. Okay. Helping with the next one with add. Helping call add quickly.
Func,
Func
Int,
of
int, comma,
int, comma, int, comma, int. So
Yes.
first was the parameters, last one is the return type. Int, comma, int, comma, int. O3 is equal to
add
Add.
and then what do we do after that? How do I call that?
console dot
It's
write
like
line
calling any other
O3
function.
O3
O3 of
10, 20.
Right. That's how I could kind of call add. Helping call the is even. What does is even do out here? What is this function returning?
Boolean value.
True or false.
Even or checking for even or
Right. Checking for whether it's even or odd. If it is exactly divisible by true, it returns true for even. If it is not exactly divisible, then it returns false. So help me with this, please.
func int comma bool
Int, comma, bool.
bool O4
Four.
equals to is even
Right. And then to call it console.write line
O4
of whatever number you wanted to
whatever
check.
number. Yes,
Are we all getting this, everybody? Are we clear about how to use func?
yes sir.
All right, let me quickly run this and output is giving you what are the 4 output it has is right. So first was the current time, second one was double of 10 it was returning, third one was adding 10 and 20, and fourth one here was returning whether 20 is true or not, whether bool is even or not. Okay, easy to use func in action. What is the distinguishing factor? When do you use
Void
func? When
return
do you
type.
use action? Yeah, void return type
And
action.
yes,
Action
sir.
is used for functions which have no return type, and func is
Okay.
used for the functions which have some return type.
Return type.
Correct. Okay. All right. Now, if you look at this function, the is even function, the return type is Boolean, and it has exactly one parameter. Okay. Now, such sort of situations will happen often in your code, wherein you may be writing functions who are taking one parameter and whose return type is Boolean. These situations would occur quite often, especially when you're writing queries, link queries. So to handle this particular situation, you can do it with func. We have done it with func on line 28. We have called it func. But we can also use another delegate called predicate. Look at the signature of predicate. What is the return type for predicate?
Bool, Boolean.
Bool. And parameters of what type? Int.
T.
Int
Int.
meaning, no, it's not int, it is in. In T, indicating what?
Generic.
Can be
Generic
any
type of
parameter.
input.
Generic.
Okay. So while giving this, it does not ask me for the return type. Why is it not asking for the return type here?
It is set to Boolean for default.
It is always going to be Boolean. So I'm going to say predicate of int O5 is equal to is even. Compare it with what we are doing with func. Func, I had to give what? I had to give the return type also. Here I don't need to give the return type. And calling it is going to be the same as before. So instead of O4, O5 of 20. Are we clear on this? So that's your predicate. Predicate is used to call functions who have a single parameter and whose return type is bool. Okay. Let's try quickly calling these. The last two is focus. Last two, both are returning true. One is being called with func and the other one is being called with predicate. Right? Questions, if any? All right. So these are three delegates, inbuilt delegates that we'll be using quite often. Going ahead, we will not be creating our own delegate classes. We'll be using what? Either action or func or predicate.
Predicate.
Questions, if any, before we move on to the next session, next topic?
No, sir.
Okay. Now, whenever you're writing a method, normally you would call the method by calling it with its method name. Correct? That's what you're doing. So most of the times you'll call it with, saying display directly. What is the other way that we've just tried with calling a method? What is the second possibility? How else can we call a method?
Using delegate.
Delegate.
Using a delegate. So which is the example that you tried on Saturday evening, and of course here also we've been trying. Now we're going to talk about a concept here called anonymous methods. Okay. So essentially an anonymous method is a method that does not have a name. Okay. Anonymous by that definition does not have a name. And then if it doesn't have a name, how do you then call a method? You can't call it with its name. That method is out. That way of calling that method is out. Right? So what is the only option left for you then? How would you call the anonymous method?
We can store
parameters.
their reference in delegate.
Using a delegate.
Yes.
See, there are two ways of calling a method. What are the two ways of calling a method? Directly, using the name. Second way is what?
Using delegates.
Using delegates. Now I'm saying that the method does not have a name. An anonymous method we'll be creating is a method that does not have a name. So if it doesn't have a name, you can't call it with its name. So the only way of calling it is with a delegate. Okay. Let's try calling this. Help me call display with a delegate. It's not, this is not an anonymous method. Right now the method has a name, but help me call this with the delegate, what we just tried.
Action.
Very good.
O1. O1.
Equals to display.
Right? And then to call it, you would do what? O1.
O1.
Right? Now this is not an anonymous method. If you want to make it an anonymous method, see what I'm doing. I'm copy pasting this method. Don't take the return type. Take only the method name. I'm copy pasting this method. I'm copying this method and pasting it here. And the method name, I'm going to replace with the keyword delegate. So this now is an anonymous method. I'll do that again. This was the regular method. Okay. If you want an anonymous method, I'm saying that, whatever you're writing in the method, the same thing will write it here. But only thing is, instead of the method name, what will you use? What keyword?
Delegate.
Delegate. So this here, from here to here, is your anonymous method. And to call the method now, how can we call it? Only possibility of calling it.
O1.
Yeah, only possibility of calling it is the delegate. You cannot call it directly. Are you clear on this, everybody?
Yes, sir.
Yes, sir.
Okay. Okay, did I need display? Do I need display?
No, sir.
No, no.
No, sir.
No, sir.
That was just for showing you what to do. Okay. That was just for showing you what to do. So basically, you just write down the whole method here itself. But use the keyword delegate. Okay, now what is the return type of this method? What is the return type?
Void.
How did you know it's void?
Action.
Because the left hand side is of type action. So the parameters to the method will have to be given. But the return type can be determined from what is there on your left hand side. Clear? Makes sense?
Yes, sir.
Yes, sir.
Okay. Okay, now most important question. What is the most important question?
Why do we use anonymous?
Yeah, why do we need it? Why do we need it? So first thing is, before I answer that question, does this remind you of some other method that you have written down earlier? Where you write a method within a method, does it remind you of some other concept?
Callback function, sir.
No.
Local
In .NET,
method.
what have we used? Local functions. So this is like a local function, a function written within a function. And in this case, what did the local functions allow you to do?
And access the variables which are in the function.
Right. A local function allowed you to access a variable which is in the calling code. Now you can do the same thing with the anonymous method. So for example, now if I do this, I can actually very easily try and access this variable I, or even change it if I want to. Okay. So again, coming back to the explanation that I gave you in local methods, that there will be situations where you need to access the variables declared in the calling code. And to do that, at that time I had said local functions, and now I'm saying what? Anonymous methods will be useful for you. So you can have anonymous methods or local functions. You could have done the same thing with local functions also. Are we clear on this, everyone? So both options are available for accessing variables declared in the in the calling block, right? And we'll see as we go along more examples where anonymous methods have to be used. there won't be an option. You will have to use that. Are we clear on this?
Yes, sir.
Yes, sir.
Okay, so I'm just writing this method for the sake of comparison. I don't need the method, just for the sake of comparison. Supposing you had that add method, okay, but you wanted to call it as an anonymous method. Help me call that. I want to call add as an anonymous method. I don't need add. I'm just keeping it for you as a comparison between the two. So
Action.
you can't use action
Sorry.
now,
Func. Sorry.
right? Why
Func.
can't we use action? First question.
Return type is available.
There's a return
Return
type.
type is integer.
Okay, good. Call out the code.
Func. Int. 3 times.
Yeah,
3
this is
times.
like RRR. Okay, int. Func int. Yeah.
O2
O2
equals
equal
to
to
add.
Okay, now I will not write add. What will I do?
Delegate.
Delegate. And then whatever you were normally writing with add,
Take two
start writing
arguments.
that. So int a comma int b and curly brackets, and then of course semicolon, because this line has started here and this line ends here. And yeah, code in there is same. What am I doing in here? Return
A plus B.
So this is defining the delegate. I don't need adder, by the way. I don't need adder. Now tell me what could I do to call it?
O2.
Console.writeLine O2 or whatever, 10, 20. That's how I could actually call that function. All right. Again, this here, starting from here, is the return type, is the anonymous method. For an anonymous method, you don't need to give the return type. Why not? Where is the return type being picked up from?
Func.
From your delegate, from this delegate. So the delegate is telling you what is the return type. Here, the delegate told you what is the return type. And the parameters you have to give, because you're going to be using the parameters in your code. So the parameters have to be given. Are we clear on this, everybody?
Yes, sir.
Questions, if any, before we move on to the next concept?
Sir, any way to address more than one anonymous function?
As in, I didn't understand it. I heard it, but I didn't understand the question.
Means like add function was there. Similarly, suppose there is a subtract function having 2 parameters. And we want to assign it in the same function, means in the same statements. Is there any way, or we'll have to write the whole thing again?
You'll have to rewrite that function in any case. You can have, O2 plus equal to.
Okay, plus equal to is applicable. Okay, sir.
Right? See, whatever you've done with delegates so far, those concepts will not change. So my left-hand side, what you did, same thing now. Now you can say plus equal to and again give delegate or whatever. But of course, we just discussed in the beginning of this session, if you're trying to call multicast delegates
Then only the
with
last
return
function.
values, then you will not get a return. But you could have done it easily with the first one. With display and show, for example, you could have done it easy. Yeah.
Yes, sir.
All right.
Okay, sir.
All right. So let's move ahead. Now, in the next example, instead of looking at anonymous methods, we're going to look at another concept which is going to shorten our code. Okay. We're going to look at another concept in which we can write a method. We can write an anonymous method in a much shorter syntax. And that essentially is your lambda. So what is a lambda? A lambda is another way of writing an anonymous method. What is an anonymous method? A method that does not have a name. But instead of writing this longer syntax, you can shorten the syntax a great deal by using a lambda. Okay, so we're going to do this in this way. Let's first write down a function. I think I just closed that window. I'm going to write down this function, which is that get double function. And we will write it using both. We'll write it using a regular function. We'll write it using a anonymous method, and we'll also see the lambda for it. So this is my get double function. Okay. Help me call get double like it was a regular function. I mean, I'm not using an anonymous method or a lambda. Help me. What will I do?
Int a
No. Using a
Delegate.
delegate. Yeah.
func
Int
int o1 equals to get double.
Okay. And then to
Call
call it, of course, console.writeLine O1 of 10. This is one way of doing it. Help me with the same thing with anonymous method. Same thing to be done with the anonymous method. Help me.
func intent o2 equals to delegate.
Delegate and then function definition.
Okay. Now with your permission, I will copy paste this and simply change what
Get double delegate.
to delegate. So this is what we're doing with the thing. Now let's try doing the same thing with the lambda. Okay, now pay attention to what we are doing with the function, what we are doing with the lambda. So the left hand side is the same. In all these examples, the left hand side is the same. Of course, the object, the reference name would change. O3 is equal to. Now, what parameter did we have? You can look either here or here. Anywhere you can look. What parameter did we have?
Integer.
Int a, right? Int a, right? So see what I'm doing. I can write it down this way, but I don't need to give the parameter type. I want to write what? I want to write int a. I'm not giving the function name also, because remember, this is also an anonymous method, but I'm also not giving what?
Data type.
Why am I not giving the data type? Why am I not required to give the data type? Where is it picking up the data type from? From the left hand side. So this first is the parameter. Then this is the lambda sign. And the second thing that I have to do now is the return value. So if you can look here or you can look here, what are we returning here?
An
What are we
Integer.
Integer.
No,
Integer.
the statement. Look at the statement. What are we returning? Not the data type. What are we returning? A into 2.
Into 2.
So you don't even need to write return A into 2. You can simply say A into 2.
Okay.
Right? And this becomes your lambda. So your lambda now has shortened your code even further. Agree?
Yes.
What did we not need to give here? We didn't need to give delegate. We didn't need to give the
Data type.
And the code inside itself. This is the return value. We didn't need to give the return statement also. So this same code, see this here first, what did we do? We did with a function. Second, we did with the anonymous method. Now the same code is expressed in a much shorter, crisper way with a lambda. All right. And then I can go and call the lambda. So help me with this console.writeLine O3 of whatever number. Look at the earlier syntax. Don't just leave it at O3. Same way, calling it will be the same way. It has one parameter. Clear on this, everybody? So here, this is your normal function. This here is your anonymous method or anonymous function, and this here is your lambda. Questions, if any? All right. Let's play around with this a little bit. Now, how many parameters did we have in this function? How many parameters did we have in this function?
2.
Do we have 2 parameters?
One.
One parameter, right? So if you have exactly one parameter, not 0, not more than 1, then the parentheses in here are optional. So I'm shortening the lambda even further. Are we clear on this, everyone? If you had exactly one option here, then you don't need to pass even the parentheses. But if you had 0 parameters, or if you had more than 1 parameters, then the parentheses are compulsory. Okay. All right. Let's now do the same functions that we did earlier in the example. I wanted to do the same functions with lambdas. Get double we have done.
So the curly braces, what about the curly braces?
We'll come to that bridge when we come to that. We'll cross that bridge when we come to it.
Okay.
Okay. Right now, the functions that I'm giving you are short functions. Let's start with get current time, add. These are short functions. Okay. Boolean is little longer. So if you have curly brackets, just write down the whole thing as it is. When you're saying curly brackets, what you mean is, what if you have multiple lines of code, correct?
Yes, sir. Exactly.
So if you have multiple lines of code, you can just write down the whole block as it is. Okay. Including the return word, including everything. Just write down the whole block as it is. But before we get to that situation, can you all help me with these lambdas? Can you all, I'm giving you time, 2 minutes I'm giving you. Right here, right now. You all are going to try this out in your book. All right. You're going to try writing the lambda in this book. Don't write the function. Don't write the function. Just write the lambdas for that. You have exactly 2 minutes.
Hello, sir.
120 seconds to give the lambdas. Yes.
In line number 45, there is like a intent. There are one is input and one is out. Oh, sorry, both
Return
are
type.
input. Return, one is return type. Sorry, and one is a parameter. What if both are different? Is like at line 60 we is even like return
they're
type is
in-
boolean, and so we
If
have to
they're
make.
both even, if they're both different, then write both different. They
Yes, sir,
don't
but
have to
like
be the same.
yes, sir, but lambda function still works. Like
Yeah, it will still work.
yes.
The parameter types doesn't have to be the same. They can be different.
No, I thought like the return type will be assigned to
No,
the
no, no, no.
A, then
What does this say? That the parameter A is of type int, no?
yes, yes, yes.
And it says this A by 2 return value is of type int.
Okay, sir.
So there's no this thing confusion.
Yes.
All right. So yeah, so you have a minute more to complete the lambdas. I have done it for get double. You have to do it for the other two right here, right now in your book. Don't call out the answer. I will tell you the answer, or we'll discuss the answer together, but don't call out the answer. I'm expecting you to write it down. If you've still not started writing, please write it down. Call out a done if done. Say done if you're done.
Done.
Others also. I
Done,
want to.
sir.
I heard only 3 duns. Others also. I get an indication then of how quick you've done it.
Done, sir.
Done.
No girls so far. All guys only answering.
Done.
Done, sir.
Guys are better than the girls. That's what this is saying. Guys are doing it faster than the girls. No girls answering.
Done, sir.
Still guys.
Done,
Come on. Some girls also answer. Done, 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 done. I want to hear that also.
Done.
Good.
Done,
Thank
sir.
you. First one. Not bad.
Done, sir.
Okay, good. Done, done, Adam, done. Not bad. All right. So let me catch up. If you're not finished, then you can have a look at this. So let's start with get current time. What is the func that you would write here? First thing is func of, this would be what? Func of
String.
string, whatever. O, see now 4
O4
is equal to, now remember this doesn't have any parameters. This doesn't have any parameters. So if you don't have any parameters, what is compulsory?
Parenthesis.
The parentheses are compulsory.
Parenthesis.
Okay. And then what are we returning here?
System.datetime. Complete line.
So this is the return value. Right? And then calling it is simple. Console.writeLine 04. All right. So this was your get double done, get current time done. Let's try add. Help me with add.
Triple
Func,
Int.
Yeah, this is the RRR example. Int, comma, int, comma, int.
O5
is
equals to A, comma B.
parenthesis,
Yeah,
A,
again,
comma,
remember,
B.
again, remember parentheses. If there are more than one parameter, then you have to give in parentheses. So A, comma B. And it's telling you also what to do. I don't even have to type it out. Okay. So this is what it's done. And console.writeLine 05 of 10, comma 20. Right? No return required. Did we have return written anywhere?
No, sir.
Anywhere did we write return here?
No, sir.
No, no. So don't write return. Return will cause you a problem. Okay. So hopefully you've got the hang of this, of what to do.
Yes,
It's
sir.
fairly simple. Just give the parameters, give the return value without the return keyword. Okay. Now, what if you want to write this is even? So one possibility of writing it, one possibility, you can write it like it has been given. So let me do it this way. Func of, help me with this. Can I use predicate?
Boolean.
Int, comma bool.
Predicate?
Yes,
Yes, sir. We can use it. Predicate.
Yes,
Could I use predicate also? No? I mean,
Yes,
Yes.
sir.
Yes.
func or predicate. I'm doing it with func, but when you are in the lab, try it out with both.
Yes.
So func of
Int,
Yeah.
comma bool.
int, comma bool 06, right? Is equal to parameters A, then the lambda expression, and then one possibility is you just, put the whole damn thing here. Okay. So this is one way of doing it. And how will I now call it? Console.writeLine 06 or whatever number that you want. So this is one way of doing it. So when would you do this? If you got multiple lines of code out here, you just put the whole function body out there. Now here, if you're putting the whole function body, the return keyword is required. So if you're putting in a function body, then return is required. If you're just giving in an expression, then the return word is not required. Okay. So this is one way of doing it. One way. All right. But can we express this in a shorter way? This will work. There's no harm in doing this. It's not wrong in doing this. But can we write this function in a much shorter way also? That is what is the essence of
Tertiary.
lambdas.
Tertiary expression.
Ternary operator.
One way is ternary. I can make it even shorter.
Directly
make it
return
even.
modulo
Sorry?
2 equal to 0.
I could not.
Directly return a modulo 2 equal to 0.
Correct. So look at this now. I'm saying func of same thing. I'm copy the paste the same thing. Func of int comma bool and 07. All right. So far the same. Take a as a parameter and return a modulus 2 equal to 0. Now what will a is 2 equal to 0 return? This whole thing will return what? This whole expression?
If it is
Either
true, it
true
will
or
return
false.
true.
Boolean got written Boolean.
Correct. It will return either true or false. So this is like saying if true, return true, else if false, return false. So why not directly return that value itself? And I could have written that code in this function also, but I just wanted to illustrate how you should try to make your lambda small out here. So which lambda is better? Look at this lambda, look at this lambda, which is better?
63, sir.
Yeah, line number 63, 07 is much better. Agree? So that should be your endeavor. Can I express the lambda in one short syntax rather than writing a long thing? The beauty of the lambda is in trying to keep it short. Okay, so the lambda is like a kiss, like a KISS kiss. What is the full form of kiss? Keep it short
Keep
and
it
sweet.
short and sweet.
Yeah. So every time you think of a lambda, think of a kiss. And that's the beauty of the lambda. Let's not discuss kisses and what goes. You all are still focused on this training module in CDAC right now, but later you will gain experience. Okay. Right now, experience more with the lambdas. Calling it, of course, was console.writeLine 07 of 10. That doesn't change. So that's how you could write a lambda. In the lab, you can just change that left-hand side instead of func of int comma bool, make it what? Predicate of int. And that would work too. Are we clear on this, everybody? This is how you can work with lambdas. Lambdas are another form of anonymous methods. So whatever you can do in an anonymous method, you can do that with the lambda also. What can you do in an anonymous method? What can you do? What is the anonymous method known for? What is the advantage of an anonymous method? Yes.
Nameless method reduces
Yes,
the
but
code
why?
complexity.
Why have an anonymous method? So that it can
Reduces the code complexity.
no.
Pass as a parameter.
Local function.
No, you can access. Yeah, it is like a local function. You can access a variable declared in the calling code. That is the reason why you have anonymous methods. So do you think in my lambdas, I can also access variables declared in the calling code? Yes or no? Possible or no? Come on, I'm telling you that the...
Yes, possible, sir. Again, using anonymous methodology.
Correct. I'm just telling you that the lambda is a shorter form of the anonymous method. All lambdas are also anonymous methods. Right? Does the lambda have any name? No, no. Are we writing a function in here or no? Is this a function or not? Yes. So this is also an anonymous method, but with this syntax, it's referred to as a lambda. And what can we do out here? We can access variables declared in the calling code. So as we go along, we will require all these features. in more advanced examples, we will require all these features. And that's where we would be using. All right. Questions, doubts, if any, with any of this so far? Okay. So we've just tried working with delegates. We've tried working with, all of these, shorter form of delegates with, anonymous methods, lambdas. So you don't need to write your own function and so on and so forth. Now let's move on to the practical application of where delegates could be used. Okay. Before I go there, I'm going to be taking one unrelated example of exception handling. So in the next part of my code, whatever code I'm doing, I would need to handle exceptions and whatnot. We have been writing a throw in between. So you do know exception handling, and I've been sort of avoiding the topic so far, but I've come to a stage where I can't sort of avoid it anymore. Now, the good news is that you already know exception handling from the previous, modules that you've been working with. And there will be minor changes here, but majority of the concepts and things would be similar. Okay. However, I want you to, think about exception handling in a slightly different way. Okay. Now, so far, when we've been writing code, there are actually 3 people involved here who are involved in this whole process of writing and running the code. One of whom is what I call as a developer. Okay. Now the developer, what does he do? He creates a class. Right? The user is also a programmer. We are also users. And this user is basically creating an object of the class. Okay, which object of which class are we talking about? The class that we have out here. And the third person that we have here is the end user. Okay. The end user is the one who runs the code. Okay. Runs the program, runs the software, whatever you want to call it. And sees the output. Okay. So there's a developer, there's a user, and an end user. Now, when you are coding, or we are coding here, we are performing all 3 tasks. We are doing all 3 jobs. So what do you do? What do I do? What do we first do? We create a class. Then what do we do after that? We create an object of the class. And after you finish trying the code, what do you do in that case?
Test the code.
So when we are testing the code, what are we doing? We are running the program. We are seeing the output, right? And then if required, we are trying it as an end user would try it. What if the end user did this? What if the end user did that? Is the end user getting to see the correct output or not? That is what we are seeing when we are running the code. Is our code running the way it is supposed to run? And to run it that way, we are performing that role of the end user. Now, my sort of observation with most of y'all is that you all don't think like these 3 different people. Okay. So what you end up doing is you're like, okay, I'm writing the code. I'm creating the class. I'm writing the code. I'm creating an object of the class. I'm doing that and I'm running the code. For you, you're the same person. In your mind, you are the same person. And what you end up doing is that things that the developer does, you sometimes write that code in the user section. Or things that the user is supposed to do, you tend to write that code in the developer section. You do that. Why do you do that? Because you are like, okay, I only have to do it. So what difference does it make to me, whether I do it here or whether I do it there? Finally, I only have to write down the code. Nobody else is doing that for me. That is your mindset. Now, that is not the correct way of approaching things. Whenever you write some code, your mindset should be, am I the developer? So am I right now, am I creating the class? If I'm creating the class, who am I? What role am I performing? I'm performing the role of the developer. Then after you finish writing the class, when you create an object of the class, where do you normally create an object of your class? In which section of the code do you create an object of your class?
Main.
In your main function. So when you write that class program and you write that main function, at that time you should be thinking like what? Like a user. At that time you should not be thinking like a developer. So your thinking should be, somebody has given me the class and I'm going to use that class. All right. And finally, after you finish coding, when you run your code, at that time, you should only be thinking like the end user. So one of the things, complaints with y'all, and one of the things I told y'all in the first day itself, is that, you know, it's a bad habit that y'all have picked up, that you create the class and then you write the main in the same class. Do you all do that? Do you all do that or no? Some of you,
Yes.
what do? You create a class and then you write that static void main again in the same class. Yes or no? Agree? I mean, I'm just, that's an observation of mine, but you all can correct me if I'm wrong.
No, sir, that's what we are practicing.
Is that yes? Is that what you're doing, most of you all?
Yes, sir.
Okay. So why did I tell you not to do that? What was my reason in telling you not to do that?
So that the code can be easy to maintain if we maintain different classes.
Not just that. That is a different issue altogether. Because I want you to think correctly. I want you to understand that the developer and the user are not the same person. The developer is the person who's creating your class. The user is the person who's creating an object of your class. These are two different entities. These are two different separate persons. But when you put the main inside the same class where you're creating, and you create now an object of the same class, what are you doing now? You're mixing responsibilities. You're then doing in one place the job of the developer also and the user also. And I want you to isolate these two. Are you clear on this, everybody? So I told you all on day one that please don't write the main in the same code that you're writing this. But in spite of that, people, you know, tend to ignore, yeah, what is the difference? I only have to write. Why should I create another class? Let me try it here only. But not the damn thing. Two things happen. First thing is your thinking gets screwed up. First thing. Secondly, you're right now in the learning stage. What's even worse is most of your concepts get screwed up. Two things happen, and both of which are very difficult to repair. First is wrong thinking. Syntax is okay. Approach is wrong. Very difficult to correct that. If your syntax is wrong, it's very easy to correct. But if your approach is wrong, then no matter of right syntax will do the right thing. Okay. Second thing, as I said, you're in the learning phase. Many of your concepts gets muddled because you're doing things that way. So in your mind, it's not a clear answer. Anyway, so going ahead, at least don't do that. Going ahead, at least don't do that. When you're 1 or 2 years experience, you know the code very well. You know, okay, even if I write it there, I know in my mind what I'm doing. At that stage, it's a different thing. At that stage, it's a different thing. So people who are telling you to do it in that same class, it doesn't matter, have done it for 20 years and then are telling you to do that. So they know in their mind what is happening, but you don't. And that's my problem. That's my problem with this approach that you have. Anyway, that's a different issue. But are we clear in our mind of who's the developer, who's the user, who's the end user?
Yes, sir.
Yes. All right. And every time you look at your code, ask yourself the question, Ki, what am I doing? Am I right now doing the task of a developer or of a user or of an end user? And you have to figure that out. Are we clear on this? All right. So just give me a minute while I copy paste some code, and I'm going to be using that code in my example. Okay, so the example that I'm going to open out here is for exception handling. And yeah, I'm ready to share my screen. So typically, what are exceptions? When you're running your code, and at this point, you're not performing the job of a developer, but you're performing the job of a user. So if you're using somebody else's code, if you're using some inbuilt classes that you've written down, that somebody else has written down. So you're creating an object of that class, you're calling a method on that class. While calling that method, if some runtime exception occurs, and the runtime exception could have happened because of different reasons. Maybe your code is not handling all situations. Maybe the user has given some wrong input. End user has given some wrong input. So when you are as a user trying to use that code, and due to certain conditions, your code crashes and an exception occurs, your program simply stops running. It does not, allow you to continue further. So that's a typical runtime error or exception that is occurring. And you need to then handle this exception in your code. And you need to, say that what if an exception occurred, then what exactly should I do? So before I show you the exception hierarchy, I'd like to just show you some of the code that I have here. And this is using a class, okay, that I am going to also copy paste out here, add a new project called exception handling. And the first example that I'm taking, I just want to show you a few of the exceptions that are occurring out here in the code of mine, and what we're doing to handle it. So consider this example. Consider this example where I'm now creating an object of some other class. Okay. I'm also calling a method of some other class out here. So at this stage, who am I? What role am I performing? The role of a user. I'm not the class developer at this point. I'm calling code from somewhere else. And I have some code that I've written down, which I wanted to predict and tell me what are the possible pitfalls or errors that could occur in this code. I have purposely introduced some errors. Can you think of what are the possible errors that could occur here?
Divide by 0. For
So,
x equals to 0.
Right. So if when I've entered a 0 out here, it could be a divide by 0.
Null
Any
pointer,
other?
etc.
Yeah. So I've purposely made obj point to null. And if everything was okay, then when you try to access obj.p1, it's going to cause you an error. Another possible error. There's one more error that's also likely to happen. You might have faced it also.
If we don't give any input.
If we give
Input
a non-number
mismatch.
as input.
Input mismatch.
If I give a non-number, what if I don't enter the integer? Then again, that will be a problem that you'll be facing. So these are the possible errors that are happening in our code. Let's run them one by one and see what happens. So if I run this with, let's say, some wrong values, some wrong inputs, and if I'm trying to convert it to an integer, line number 10, that line causes me a problem. So what is the problem here now? This is the exception, system.format exception. Input string was not in a correct format. So this is one possible exception that is occurred. Now, if I continue running my code, you'll find that my program has crashed and it shows me the unhandled exception, and this is what is actually happening. Okay, so your program has exited and in between itself. It's not gone on to the next part out here. Let's try the second possibility. Now remember these names, okay? Format exception was one such exception. Second one, somebody suggested, what if I enter a 0? So you get your divide by 0 exception, attempted to divide by 0. And if I, continue running, then it shows me the exception out here. Okay. The third possible exception that could occur is if I gave all correct values. And now if I try to access this, it gives me a system.null reference exception, which is because you're trying to access obj.p1 and obj is currently null. Now, all of these that you saw were exceptions that occurred, there is a certain hierarchy. All exceptions that you see inherit directly or indirectly from the system.exception class. Okay. Now the system.exception class has two further classes under it. One is the system exception and one is the application exception. So both these classes inherit from from exception class. Okay, just quick question to you. When you see this output here, does that for me, my screen is being hidden by the window which shows the people attending the training. Is that window shown to you also?
No, sir.
No, sir.
Yes, sir.
Can you read the whole word application exception?
Yes, sir. Yes, sir.
Okay, fine. All right. Yeah. So anyway, coming back to this, so I have application exception and system exception. So both of these inherit from the exception class. The system exception is used as a base class for all inbuilt .NET exceptions thrown by .NET code. All of these inherit from system exception. Whereas application exception is meant for any custom exception classes that you create. So what are the custom exception classes that, if you create your own exception classes, it's suggesting that you inherit from application exception. So initially this would be blank. There'll be nothing under that. This is meant for your classes. Let's pay attention to the three exceptions that we saw out there. One of them was divide by zero exception. Now the divide by zero exception inherits from system exception, but does not do so directly. This divide by zero exception actually inherits from arithmetic exception. Right. So if you, for example, if I've written divide by zero exception, this class is inheriting from where? Arithmetic exception.
Arithmetic exception.
And arithmetic exception itself is inheriting from where?
System
From
exception.
system exception. So that's the hierarchy that I was talking. Okay. On the other hand, some of the other exceptions that we saw, let's say format exception. Okay. This inherits from system exception, or the other one that we saw was null reference exception. This also inherits from system exception. Right? Now, besides this, these are the exceptions that we saw in our code. Besides these, there are many more exception classes that are there that would directly or indirectly inherit from the exception class. Okay. Now, when your code runs and when your code crashes, what is being thrown is an object of one of these classes out here. So for example, if I entered this, what is happening is the code that is being called. What code am I calling? Convert dot to int 32. So that code is throwing an exception. So you're right now a user of that class. What class are we using?
Convert.
What? Convert. And that has a method called toInt32. So when we are using that method, it's causing you a problem in your code if the input is not correct. And if you don't catch that exception, your code simply crashes. Okay. Now let's look at a few of the properties out here. So to see few of the properties here, I'm going to go into view details. And in the view details, it shows me some of the properties of the format exception class. One of the properties there was message. So what is message now? Can you make out what message is? What is it showing you in message?
What
Yes,
we want
please.
to show to the user.
This is the error message that is being generated out here. What is the reason for the exception occur? The source, on the other hand, can you make out what source is? Can you identify from here what the source is? What does source tell you? Come on, there's a big clue out there.
System.
What does source mean in an exception?
Exception is generated.
The code from
Oh,
which exception was
yes.
generated.
So instead of the code, give me a better word. What do you see here?
Package.
Wait,
Namespace.
.NET you don't use the package, no? What do you use?
Namespace.
Namespaces.
Nahi darling. In .NET you use an assembly. Yeah. If you're writing Java code, then you say package. If you're writing .NET code, you say assembly. So you need to have that clarity of thought when you're going in for your interview. If you're going in for Java interview, you say package. But if you're going for .NET, don't call it package. The guy who's taking your interview will make it a point. Yeah, he doesn't know what is an assembly. So the source is the name of the assembly which threw the exception. Okay. All right. Any guesses? I'm not asking you to know what this is, but any guesses what target site would be? Any guesses what target site would be? Yes. Come on.
Maybe sir, like the catch block in Java. No?
The target site is the name of the method that threw the exception. So source is the name of the assembly that had the exception, that threw the exception. Target site, on the other hand, is the name of the method that threw the exception. Are we clear on this, everybody? That's
Yes,
your
sir.
target site. Okay. There is also something called stack trace. So there's also something here called stack trace. Any guesses what stack trace could be?
It traces the line which throws the exception.
Right. So it gives you all the methods that were on the stack when the exception occurred. So if you look at this code, where did we call this code from? We called this code from where? From main. So main called what? What did main call? Come on.
Convert method.
Convert is not a method. Convert is the class.
Class.
Yeah. So 2int32 method, which is in the convert class. Right? This is what your main called. So see this. Now you go reverse. It's a stack. So main was the first function that was called. Main called what? Convert.2int32. And convert.2int32 called this method. System.number.throw_overflow format exception. And this was the exception. Throw overflow. This was the name of the method that caused the exception. Throw overflow or format exception. Are we clear? But how did that method get called? That got called from where? From convert.2int32. Which got called from where? From main. So it shows you all the functions on the stack when the exception occurred. And this allows you to debug your code. Why did my exception occur? What was the flow? How did I go to that method? That will help you answer these questions. Now, all these message, source, target site, stack trace, all of these are properties of the exception class. And because all of these other classes inherit from exception, all the other classes also get these same properties. They're getting the properties from that exception class. Are we clear on this, everybody? Questions, if any? Okay, one more. I didn't show you this. One more property there, which right now is null. Okay, I was pulling in the wrong place. There's one more property right now which is null, which is the inner exception. So the inner exception will give you additional details about why the exception occurred. So you might have a external exception and then additional details would be in inner exception. Inner exception is of type exception itself. So inner exception again will have what properties? Again will have what properties? Properties like message, source, stack trace, all right, target site, all of these properties will be there. Inner exception again will have inner exceptions. Sometimes you might have, nested exceptions that are being thrown. Keep, one exception contains details about others, others contain details about third, and so on and so forth. Like there might be a database exception. Database exception is, inner exception might be constraint exception. Constraint exception, inner exception might be primary key exception. So you might have a nested set of exceptions with inner exception. Right now, of course, it is null. In further examples, you may be required to use this. All right, so this was details about the exception. Now we need to call, or rather we need to make sure that our exception, doesn't crash our code. So we need to put our code into a try-catch block. And this is where now all the options with try-catch block. So I'm going to go a little quick on this. And you tell me what is happening out here. What have I done out here? If an exception occurs, how will it go? What will be the flow? What would happen if an exception occurs? Where will it go to?
The exception will be caught by the catch block, and then this exception occurred message will
Sir,
appear.
because we haven't given any exception in catch block.
Correct. So I'm taking a very simple try-catch block. If an exception occurred, like the format exception occurred on line 20, from here it will directly jump to line 25. It will directly jump to the catch block. From here it will jump here. It will not execute the remaining lines of code. And in here, right now, for all exceptions, it will go and show you what? The same message right now, which said exception occurred, and it will then come out of your code. The difference from the earlier code is it will not crash your code, it will not end your program. Your program can continue working, and you can write error handling code out here. So this is the simple try block with catch. All exceptions are caught out here. Clear? If no exceptions occurred, if all this code ran correctly, then the catch block would not be called. It will go to the statement after the catch block. Let's try this. First, let's try with an exception. So whatever exception occurred, now, it just simply goes and shows me what exception occurred. So whether it is a format exception or whether it was a divide by zero exception, sorry, this is still a format. This was a divide by zero, or whether it was a null reference exception. All of them, it is only showing me what exception occurred. Achha, now when I got a null reference exception, it waited for me to see this. It waited for me to see this. Now, why is it waiting? Because of this option, which says that break when the exception type is thrown. If you deselect it, then the code will not wait for you. Okay, I'm not deselecting it. So if I press F5 now it goes into the other part of the code which shows you what exception occurred. All right. Okay. So this is a simple try catch block. Now, what if there were no exceptions? Let me remove this line and there were no exceptions. And if I give everything correctly, then what will happen? The no exceptions part occurs. And then after that, it goes to the code after the catch block. So the catch block would not run here at all. Are we clear on this, everybody?
Yes, sir.
Questions if any. You have done this before, so I'm going a little quick on this. If you are not understanding any section, then slow me down by asking me a question. All right. Now, in the previous example, we didn't know which exception occurred. So all exceptions were being caught common here. Now, if you wanted to write different code for different exceptions, okay, you could write it down this way by having multiple catch blocks. Now, it will go into the catch block only if that exception has occurred. So let's say an exception occurs on this line. And the exception that occurs now is what? When you're trying to convert is format exception. So it will jump from here and try to go to the first catch block. Now it cannot be caught in this catch block. So it will ignore this, jump to the next catch block. Cannot be caught here again. Ignore this, jump to the next one. If it can be caught, then it will go into the catch block, execute the code, and then come out outside all the catch blocks. So for example, if you had entered 0 and an exception occurred here, it will catch it here, do this code, but now not check the code for any of the other catch blocks and move outside that. That's how your try catch would work. You can either catch us, just doing this, or catch a specific reference out here, which you can later use in your code. I haven't used the reference in my code, but in a later example, I am using it. So I can catch it in this. Any queries or questions with any of this? Yeah, any queries or questions with any of this?
So just if we take a catch block without any parenthesis, it will act same as we take a catch block with exception as a parameter.
Correct.
The exception class.
But the difference is that if you said exception EX,
Yes, sir.
then the properties of that would be available to you. With this catch block, you will not get to see the properties.
Okay.
So other than that, they are both the same. Okay, so this is the second example that we tried out, a try with multiple catch blocks. I'm not running the code. You can try the code in the lab and try out various combinations with this. Coming to the question that he asked, right? Again, another important concept, catching a base class exception. So we saw the hierarchy sometime back, and this is the hierarchy. So if you looked at divide by 0 exception, now divide by 0 exception can either be caught by divide by 0 exception or by any of its base classes. So the base class that we're using here is
Arithmetic exception and system exception.
Or system exception or
Exception.
Or exception itself. So you can catch it anywhere. So let's try doing this. If I try catching it, divide by 0 exception, it will catch it here. It will catch it here. Okay, I don't have renamed main. I'm not renaming main. And if I enter 0, you could catch it there. Second possibility is instead of catching it as divide by 0 exception, you could also catch it as any of its base classes. So let's say arithmetic exception. And again, the same thing being caught. Or can be caught with, also caught with system exception. Again, the same thing can be caught. Right? Or with the exception. I'm not trying with the exception here, but if you comment out this code, then you'll catch this one. All right. Now, if I try doing the same thing with format exception, what are the base class for format exception? Base class of format exception is
System exception.
system exception. If I try doing that, it causes me a problem because system exception also happens to be the base class of null reference exception and, of course, and divide by 0 exception. Indirectly, of course. Both these blocks give me a problem because now this is unreachable code. I will not be able to reach the null reference exception because all null reference exceptions will also be caught by system exception. Right? Similarly, all divide by 0 exceptions will not reach this point at all. It will simply be caught out here. So why didn't I face a similar problem when I did this? Why didn't I have a problem with this one, with this system exception? It also happens to be the base class of format and null reference exception. So why did this work, but why didn't this work?
Because the base class exception should be always placed in the end of all the exceptions.
But why did it work? That is the rule you're telling me. You're telling me that is the rule. But why is it that way?
There can be another exception can occur here that will catched by system exception.
My question is different. You all are not understanding my question. You all are telling me statements which are correct statements, but not the answer to my question. My question is, why did system exception work later, but not at the beginning?
Sir, we write it in the beginning, then the code which is written below it becomes unreachable.
Because the order of the execution, that is the answer I'm looking for, is from top to bottom. So when you start at the beginning, to reach null reference exception, you have to pass by system exception first. And therefore, this becomes an unreachable block. But when you write it at the end, then all your derived classes have been written below, were written before, and you have passed through them. So you can reach format exception. You can reach null reference exception. And if it is not any of these, then it will go and check out for system exception. So format exception and null reference exception are now, possible. You can get into that. And yes, then you can say what you were saying, which is that therefore, the base class exception has to be caught at the end after the derived class exceptions. The order has to be derived class exceptions come first and base class exceptions come later. But the problem with a lot of y'all are you all know the answer, but you all are not answering the why. If I'm asking you this in the interview, listen to the question carefully. What is he trying to ask you? Don't just randomly give out Rattamarofite statements. You know your concept, but correlated to the question, why? Now, the two answers that I received are not wrong statements, but the explanation didn't come in there. That didn't shine through. So that is how you need to answer a question in the interview. Your why is very important. Nobody is checking whether you know the statement or not. Why are you doing that? If you know that, then you're a good coder. So anyway, coming back to this. So yes, you all are correct. The base class exception has to be given right at the end because of what we just discussed. Right? I'm not running this code again. You can try this code out in the lab. Okay, I have a little time for me to complete the finally and the others. You could also optionally put in a finally. Now the finally block would run in both situations, in all situations, in fact. First possibility is that the exception did not occur. If no exceptions occurred, then your code and finally would also run. The second situation is if an exception occurred, then also your code and finally would run. Now your exception occurred or was not caught or caught. In those situations also your code and finally would run. So essentially your code and finally would run in all cases. And this is what we call as cleanup code. Typically common code that needs to run, whether the exception occurred or didn't occur, that would come up here in finally. Right? Are we clear on this, everybody?
Yes, sir.
Okay. Any questions about this?
Sir, is there any case where finally will not run?
No. It will not run if you pull out the plug on your system, maybe major crash. Okay, something like that. I mean, something totally unforeseen. Your system just melts down. Your hard disk crashes. Somebody comes in, smashes your CPU, whatever. Those sort of cases. But otherwise, code would run. All right. I have code after finally. Would this code also run in all situations?
After finally, yes, sir.
Will it run in all situations?
Yes, sir.
No, sir.
No, sir.
When will it not run?
There is any exception.
If the
Which is
exception
not
is not
handled.
caught, yeah.
Which is not handled. And the code after finally will not run. So that's the difference between finally and after finally. Also, one more situation. Supposing you're writing a function. You're writing a function, and in your catch, if there is a return statement, what does the return statement do? If you're writing this code in a function, what will the return statement do?
Transfer the control to calling code.
Control will go back to the calling code.
Yes.
Yes, sir.
But if you have code in finally, it will first run the code in finally and then return. But if you have code after finally, then that code will not return. So these are situations where code after finally will not run, but finally will run. Okay, one is what exception occurs and is not handled. Second is if you're having a return statement that you're putting in the function. Then in these situations, that code in finally will run, but not in the after finally. Okay. So again, I'm not trying out the code. You can try this out in the lab. This is a concept that you'll have familiar with. Okay, I have enough time to just show you one last example, which is a nested try block. Now, if you have a nested try block, essentially what you're saying is that you could have a try within a try, or a try within a catch, or a try within a finally. Okay. And each of the tries have their own structure. Here, what do I have? I have an outer try. But within the try, there's a catch. And within that catch, again, what do I have? Again, I have what? Yes.
Try, catch, and finally.
A try, catch, finally. So now, if an exception occurs, if let's say the format exception occurs, then we go into this catch block. Then again, we are doing a try. If an exception occurs here, it will go into this catch block. And this code will have its own catch mechanism. That's what we're trying to say out here, that you could have nested tries. Again, you could have, each try could have its own finally, if you want to. Right? Okay, by the way, I haven't said this, but a try must have at least
One
of
catch.
catch or finally. Right? Catch or finally. You can't write it without a, you can't just write it by itself. So you have, maybe then exception occurs. You want to let the exception occur, but before it ends, you want to do a finally. Right? So that is something that you might have, or you might have a catch as well. You have tried to try with the catch. So this is what we're trying to do. What is this code actually doing? If a format exception occurs, what am I trying to do again? What am I trying to do again if a format exception occurs?
Again, take input from the user.
Again, take input from the user. Now, if it fails second time, then say, sorry, there's a problem with this. So you're giving him one more chance if the format exception is occurring, if he's not entered the number correctly. Now you have to try it out with all various possibilities. Firstly, try it out with no exceptions. If no exceptions occur, then what will be the sequence? Try none of the catches, and this finally, with no exceptions. If this exception occurred, if the format exception occurred here, okay, then firstly the try, from here it will jump to the format exception. Now in this code, if there were no exceptions, then the code in the finally, and then the code in the outer finally would run.
Finally.
In this code, if there was an exception, then the code in the catch, and then the code in the finally, and then the code in the outer finally would run. So you have to try out all these permutations, and you have to try it out with different examples. I'm not trying it out. I'm leaving it to you. We're anyway out of time, so we don't have too much time to try this out, but at least try these examples out. Okay. So we have sort of, I'll go back to my explanation here. We have sort of dealt with what to do when the user creates an object of the class or is calling some code on that class. And if this user faces an exception, then what is to be done? We have done that part of the code, right? When we come back in the second session, we look at the second part of the code. Okay, what about when you're creating a class and if an exception is to be generated, then that aspect we'll discuss when we look at it the second time now. Okay, but that's all for now. I'm sort of run out of time, so to say.